All right, greetings, ladies and gentlemen. We're just going to do a quick review of some things about complex numbers and imaginary numbers. So that's what the whole point of this is, just remember these things. Yeah, okay. Let's start with thing one, powers of I. So once upon a time, you learned that I is the square root of -1. That is not a real number, it's an imaginary number. In fact, we call I the imaginary number. And if you put different powers on I, you get a little bit different things. Like if you square I, well, that's squaring the square root of -1. You get -1 out of that. If you have I to the third, well, that's going to be I times I squared. And we already know that I squared is -1. So that makes it I times -1, which means it's negative I. So I and I to the third are almost the same. It's just I to the third's negative I. And then you got I to the fourth. Well, I to the fourth is the same thing as I squared times I squared. And we already know I squared is -1. So it's -1 times -1, which means it's just 1. So I to the fourth is 1. And so if you get even higher, this turns into, well, a cycle of what's going on with the powers. I to the fifth is the same as I to the fourth times I. And we already know I to the fourth is 1. So it becomes 1 times I, which means it's I. And so you get this cycle of I, -1, negative I, 1, and things just kind of cycle through those different results there when you get bigger and bigger powers of I. And so if you want to do 3, and you want to times it together, well, you just add up all those exponents. It becomes 2 plus 6 plus 5 power. Let's see, 2 plus 6 is 8, plus 5 is 13, so we got 13th power. Well, we can rewrite this as I to the fourth twice. Oh, actually, we can do that 3 times. Sorry. Times I to the first. Because I to the fourth to the third is 12, and then this makes 13. So really, I should have written it out that way. I to the 12th times I to the first. I to the 12th is I to the fourth to the third power, which means I to the 12th is just 1. So now we got 1 times I, so it's just I. There we go. Problem simplified, it's just I. Or the imaginary number. And you need to be able to deal with I in certain other contexts, such as you got to multiply these two things together. Well, it's not too bad. Remember, you take the first term, you times it through, you take the second term, and times it through. You end up with 3 minus 18i, and then minus 2i, and then plus 12i squared. Now, it's kind of just like a normal multiplying two binomials together. It makes kind of a quadratic looking thing. And we're going to simplify this. So you got 3 minus 20i plus 12i squared. But we're not quite done, because this can be simplified more. Because remember, I squared is -1. So this turns into 3 minus 20i, not 30, minus 12. And then these can combine, and you'll get -9 minus 20i. And now it's done. We got it all simplified. On all of these, you shouldn't have any powers of I bigger than 1, because they simplify to be other things. Looks like a U there. Try to make it I like. Alright, so there you go. That's what's going on in the first section. And the other thing to remember about complex numbers is that you can graph them. And the way the graphing works is each complex number has a real part and the imaginary part. You graph the real horizontally and then the imaginary vertically. So this complex number, -6 minus 6i, is almost like the point -6, -6. But the second -6 is an I value, imaginary number value, and this is the real value. And we graph these as vectors. So we're going to go left 6 and down 6, which is down here in the bottom left corner. But we're going to draw a vector that goes to it, just like that, and it ends there. And ta-da, we have graphed the complex number, but we also need to calculate its modulus. To get the modulus, you just need to find how long this is, which is pretty much just the hypotenuse of a lovely right triangle that's got sides of 6 and 6. We need to find our modulus. And so the modulus sorry, is going to be the square root of 6 squared plus 6 squared, which is the square root of 72, because 6 squared is 36, 36 plus 36 is 72, and you can simplify that radical, because remember it's 36 times 2, and 36 is 6 times 6. So you got a pair of 6's, and so our modulus is going to be 6 root 2. And ta-da, we got it. We graphed it over here on our left side, and its modulus is 6 root 2. So there's your review of complex number things.